Welcome to The Explainer. Today, we're diving into something absolutely fascinating, architecting a career in modern robotics. Now, if you follow the industry, you already know that building an autonomous system is incredibly complex. But what we're going to unpack today is how you apply that exact same level of systems engineering to your own professional trajectory. Think of your career kind of like building a complex machine from the ground up. It requires a really solid foundation, super precise integration, and a clear blueprint. So let's jump right in with the million-dollar question, the one that's literally keeping industry leaders up at night. How do you close the skills gap between mechanical design and real-time software engineering? This is a massive, vital chasm in the robotics industry right now. We've got brilliant mechanical engineers designing these incredible physical structures and genius software developers writing bleeding-edge code. But there's a glaring disconnect. Making those two worlds talk to each other flawlessly is where the entire industry is bottlenecking. Bridging that gap is exactly what we're going to figure out today.
Here's our architectural blueprint for today. 1. The hardware-software skills gap. 2. The robotics knowledge pyramid. 3. IEEE standards and communities. 4. Defining your robotics pathway. And 5. Building your professional portfolio.
All right, Section 1, the hardware-software skills gap.
This brings us to the real hero of our story, the systems engineer. This is the absolutely critical professional role responsible for bridging that void between mechanical hardware design and real-time software engineering. Look, if you've ever seen a software team blame the hardware team, or vice versa, which happens all the time, you know exactly why this matters. If you're aiming for a career in robotics, this role is the ultimate bridge builder. You aren't just a coder and you aren't just a fabricator. You're the architect who connects the physical framework with the digital brain. You make sure the sensors, the actuators, and the algorithms are all speaking the exact same language. Watch out, though, because there's a massive pitfall here, and that is thinking specialized robotics is purely a software or purely a hardware field. If you get tunnel vision and only focus on one single discipline, your career structure is going to inevitably collapse when you face real-world integration challenges. The modern robotics industry doesn't want someone who just throws their work over the fence to the other department. No way. They need systems thinkers who respect and deeply understand the whole shebang, both sides of the coin.
Moving right along to Section 2, the robotics knowledge pyramid.
Think of it like a literal physical pyramid.
You just can't build the peak without a massively wide, stable base. Step 1, your base, rigorous math and physics. You have to instinctively understand the physical laws governing your robot. Step 2, that middle layer, is where you begin to specialize across disciplines like computer science, mechanical engineering, and electronics. You're essentially weaving together the coding with the circuitry and the kinematics. Only when those two foundational steps are rock solid can you actually reach Step 3, the peak. Autonomous systems. This is where the magic happens, where perception, planning, and control all unite. But always remember, the peak collapses without the base.
Now for the building codes in Section 3, IEEE standards and communities.
A solid, real-world structure requires strict adherence to technical standards. You really can't just build ad hoc. First up, mastering the IEEE Robotics and Automation Society, or RAS, standards is simply non-negotiable for a recognized career in this space. Second, you've got to have the ability to navigate an IEEE Explore literature review. Why? So you aren't constantly reinventing the wheel. You need to know what state-of-the-art actually looks like right now. And finally, for your professional placement prep, you need to interpret what's called a company assessment pattern. This basically means understanding exactly how robotics firms evaluate your multidisciplinary knowledge during their high-pressure hiring processes. To really grasp the stakes here, consider this incredible case study. Evan Beard, the CEO of Standard Bots, has actually been testifying to Congress on the need for a national strategy for robotics. We aren't just talking about academic exercises here. The lack of standard integration and a clear national strategy, that's a macroeconomic issue. Industry leaders are literally taking this to the highest levels of government to advocate for standards and systems engineering practices. That is the exact area you're stepping into.
Let's bring this down to earth and look at some data. We're comparing the monthly traffic of top platforms, specifically Robot Forum and RoboHub. This data is absolutely vital. Why? Well, because you need to know exactly where collaborative communities are clustering to identify industry trends. If you want to know what middleware is frustrating engineers today, or what mechanical components are consistently failing out in the field, you don't wait around for a textbook to be published. You monitor the live traffic and the chatter in these forums. Engaging with these communities is exactly how you stay ahead of the curve.
Which brings us to Section 4, defining your robotics pathway.
I'm going to directly challenge you to evaluate your current skill set right now. Integrator role versus research role. Which path actually aligns with your strengths? The integrator takes existing, proven components, sensors, arms, software packages, and forces them to work together seamlessly on a factory floor. They're highly practical, boots on the ground, on-the-fly problem solvers. The research role, on the other hand, is pushing the boundaries of what's theoretically possible. They're developing novel algorithms or entirely new actuator concepts. Both of these are absolutely vital, for sure, but they require very different day-to-day mindsets. You really need to map your career architecture to the right role. And that sparks a crucial 2026 industry debate. Is a traditional university degree better, or is the future all about a certification plus portfolio path? The landscape is shifting incredibly fast right now. While the traditional degree definitely provides that rigorous math and physics base we saw on the pyramid, the industry is becoming heavily biased toward engineers who can demonstrate practical, modern skills through specialized certifications and, most importantly, a tangible portfolio of work. Actually, the ideal candidate right now often blends the absolute best of both worlds.
All right, the final inspection. Section 5, building your professional portfolio.
Here is your concrete checklist to practically prove your systems engineering skills. Number 1, build an open source portfolio using Git. Look, if an employer can't see your code and how you manage version control, you effectively don't exist. Number 2, master software middleware integration. Show them you can make a camera actually talk to a robotic arm in real time. Don't just hand them an isolated script. And number 3, if you're just starting out, utilize the IEEE RAS pre-college resources for foundational prep. It is literally never too early to start aligning yourself with professional standards. It's all about creating undeniable, highly visible proof of what you can do.
So, we've walked through the complete blueprint, from the foundational math to the peaks of autonomy, right down to the community standards that hold the whole thing together. I want to leave you with this provocative thought. Are you ready to architect the autonomous mind? And more importantly, having seen the blueprint, which path will you take to bridge the hardware-software gap? The industry desperately needs systems engineers who can build these bridges. The roadmap is right in front of you. Now it's time to start building. Thanks for joining me on this explainer, and I'll catch you next time.